What's up, guys? Let's solve some more LeetCode today. We're solving minimum size subarray sum here. Okay, so the idea of the problem is we're given a array of positive integers and a positive number, integer number target, and we want to return the minimal length of a subarray whose sum is actually greater than or equal to the target. And if there's no subarray, then we just return 0. A subarray is a contiguous non-empty sequence of elements within the array. And if in this case, if we take a look at this guy, target is 10. The subarray 5, 1, 11 has a minimal length under the problem constraint. Okay, there's a minimum length, right? There's a minimum length of 3 in this case. So you're given an array of positive integers nums and a positive integer target. Return the minimal length of subarray whose sum is greater than or equal to the target. Greater? Oh, minimal. So we want to find the minimal guy whose subarray is like that. That's great. Yeah, this problem definitely reminds me of sliding window algorithm. Yeah. Because so basically, how are we going to get I think it's best just to look at the blackboard here. So if we look at this guy, let's take a look at these elements like this. So if I have 2, 1, 5, 1, 5, 3, how am I going to find the minimum sort of like array, right? Now we know that this is actually this is a minimum array that is less than 10, so that can't be it. We want it to be greater than, but we want the minimum to be. So yeah, so we want like the biggest elements inside, right? So this is the result. That's the smallest subarray that is also actually small subarray that is also, what do you call it, like very I don't know, useful, I don't know, like satisfying the target, right? The sum of this is 11, which is greater than or equal to 10. So this is a pretty typical sliding window problem. Now the idea behind this problem is it's sort of like a dynamic sliding window. We're just gonna have like where basically we're gonna start off with like 2 pointers right here, and our left guy is gonna be like over here, and our right guy's gonna also start over here. And initially we're gonna start off with like a sum, right? And our sum is gonna be simply like a 2 for now, and then we check and see that our sum is okay. So basically let's write down our conditions. What are our conditions? Our conditions are that minimum, we want the minimum subarray, right? We want the minimum subarray, and also there's one more thing. We need the sum to be greater than or equal to the target. Which, what is our target? In this case, we could set our target to be equal to 10. And we'll say t equals 10 is our target, okay? So in this case, target is equal to 10. Okay, so we have 2 here, and we notice that our sum is obviously much greater, no, much less than 10, right? So we can actually increase this pointer here. So this pointer, erase this pointer now, and then this pointer comes to over here, and now we have 3. Now this value becomes 3, right? And then we know 3 is still less than 10. So what we do now is that we're going to get rid of this guy, and we're going to go forward here. So now we have 8. Now you become 8 here, right? But the thing is, 8 is still less than 10. So we want more values to basically get until the max value that we have. So then we include 1 here as well. And we get 1, and we have 9. So 9 is still less than 10, so we're going to add 1 more value here. So when we get 5, and ultimately we're going to get 14. Now 14 is greater than 10. But we don't now basically we have met the requirements. We have met this requirement number 2, right? If this is requirement number 1 and requirement number 2, we've met requirement number 2, but we want to check and see if we can sort of like minimize requirement number 1. This is not really a requirement, it's more like a we can think of it like sort of like a minimizing factor that we want. So basically we want to minimize factor. So the idea is we're going to sort of like subtract all the elements along left as we iterate, as we bring left back up 2 values. So basically 14 here, right? And left is currently on 2, so we're gonna be okay. We're gonna take away left, and left is now pointing to here. So okay, that's great. Now that we have 12, is 12 less than 10? No, it's actually greater than 10. So we can continue doing that. We can continue doing it and seeing how small our subarray can get. So we come down to here and we see, oh, let's go down to 5. And we get to 5 and we subtract 1, so we get 11. Okay, that's still greater than 10. So we're gonna check and see if we can subtract it again and see if we can make it. And we get to 1. Oh, 1 plus 5 is 6, not 9. Whoops, it's 6. But that's less than 10. So I guess we can't do that anymore. So we need to start iterating this guy, and we're gonna iterate to the end, and then we're done our algorithm. And along the way of each iteration, each iteration mainly for the left pointer. Yeah, mainly for the left part, but also I think the right protocols work. We're going to sort of like our result is going to be the minimum sub array, right? So like I'm literally just going to write this in code. It's just going to be max value between the result and the right minus left pointer, I believe. Yeah, right minus left pointer plus 1, because we should include, in the case that they're both on like one element, that length is going to be 1. Let r plus right plus 1, right? 1, like this. R plus left plus right plus 1. Yeah, so that's this max right here, and I'm pretty sure that's just result. I'm gonna code it up, see how I can do. Yeah, I think that's it. We're just gonna use a sliding window. Let's see if I know how to implement this. Okay, so what do we need? We're going to first need a result, which is equal to the minimum length, right? So our minimum length, for now, we're going to initialize this minimum length just to the length of the nums. So basically the idea is we're assuming that the minimum length is just the whole length of the array. I guess like sort of like a clarifying question. Can we always assume that there is values inside of this nums array that we can use that add up to target, right? For example, we're always assuming that target can be added with all, if we added all the values. Well, like the condition that the sum of a subarray is greater than or equal to the target can always be met. Is my question. Okay. And is there ever a case where we're given like an what are the constraints on these numbers, like the numbers inside of nums and target? They can be negative and anything like that, right? Yeah, okay. It's not sorted at all or anything, right? Okay, sure. That's good. Okay. Yeah, so why don't we continue with the demonstration? So basically we want to implement, what we want to implement is just a sliding window. It's just like so our left pointer is going to be starting at 0, and then our right pointer is also going to be starting at 0, right equals 0, and we should also track our current sum, which is just going to be equal to nums at 0 for now, because we just keep adding stuff, right? So basically yeah, we don't need a right here. We're going to say for right in range from 0 to nums. So the idea here is we're going to actually add to current sum each time. So basically we just do current sum plus equals, I think it's plus equals nums at right. And then as we get to that, so let's go back to our drawing. There was 2 cases that we sort of considered, right? we just kept adding this until we noticed that our current sum, this is our current sum, right? We noticed that our current sum is greater than 10. So what does that mean? We should keep adding until our current sum is greater than our value, right? So yeah, and we noticed that while our current sum was actually like that, we kept incrementing the left pointer like this, right? So yeah, so while our current sum is actually greater is greater than or equal. No, wait. Is it possible to have 0? Is it possible to have 0? Okay, it's not. But this is gonna work for 0 if we do like this. If it's greater than or equal to our target, then the idea is we're just gonna increment this guy. Yeah. Plus equals 1. We're gonna increment the left guy at the end, but the thing is we should do current sum minus equals the nums at left. So the idea is here we're basically just simulating this. So we have a current sum that represents all the sum values all the way from here to here in this case, right? And what we want to do is we want to just subtract this value, which is basically like moving this pointer up and saying our new sum is this amount, right? Yeah, so that's what we're doing. Yeah, so I'm just doing this here right now. Yeah, so we do that, and then so our current sum minus equals nums left. That's great. And then left plus equals 1. And one thing we're forgetting is every time we do this, we should do this. Result equals the max between result and what we basically wrote down, right? Which is just right minus left plus 1, right? And okay, that's great. That's amazing. Yeah, so I think it's only gonna go higher from there. So we can just return result and see how that goes. Not sure if there's like syntax errors or anything. Okay, for right in range of length of nums. Whoops. Okay, we got the wrong answer. Let's see what's wrong with our answer. So far this is returning 6, which is the whole length of this guy. So let's actually go through and see what's going on here. So we're iterating through and saying we're gonna add to our current sum the current numbers over here, right? And so while current sum is greater than or equal to the target, then we're gonna subtract from current sum, and we're gonna set the result equal to this guy. The max between the right pointer and the left pointer plus 1. Okay. I think it might be best just to print out current sum to see what's going on with that. Let's see. I'm curious what's going on here. So we have 0, 2, 3, 8, 9. And if we take a look at this guy, we go 0. Yeah, so it starts off as 0, of course. 2, 3, 8 is correct. 9 is correct. And we go down to 6, which is not so right. Actually, yeah, no, wait, this is correct because I'm printing before. So actually, yeah, this is right. It's better to print it like this because this makes more sense. It would not confuse me. So we get to 14, and then we end up subtracting what? We subtract number there. We subtract. We keep subtracting. Oh, it's a min. Whoops. Whoops. Okay, so it's expected output is 0 in this case. The target is 5. You notice. Okay, so it's initially set. Okay, so in this case, the target actually is not met, which was something I wanted to ask as well. Okay. It's great. Yeah, so I guess an edge case would be just to sum up all the nums here and see if it's like greater. If it passes the test, and if it doesn't pass the test, we'll just obviously return 0. Okay, if the sum, or like, what was it, nums, the sum from, I don't remember, nums.sum from 0 onward. Is num.sum is less than, strictly less than target, they're just gonna return false. Or return 0 in this case. Let's see if my syntax works. Okay, I don't know how the syntax works. Sum. Wait, let me just go VS Code. Okay, where'd it go? Sum. Okay, so you just call sum on the whole thing and it just does that for you. Okay, that's great. Yes, the sum on nums, right? So we just do that and we're good. Nice. Let's see. Will work. Let's go. GG's.